Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy them. So check out Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And don't forget to go to dataengineeringpodcast.com/chat to join the community and keep the conversation going. Your host is Tobias Macy, and today I'm interviewing Kevin Dewalt about his experiences at Prolego, building machine learning projects for Fortune 500 companies. So, Kevin, could you start by introducing yourself?
Well, thanks a lot, Tobias. And first, let me just thank you for being on the show. You've got a great podcast here. Our team is subscribers and we're fans, and it's really an honor to be here with you today. So thank you. I'm Kevin Dewalt, co-founder of Prolego. We are a boutique consulting company which helps large organizations achieve business goals with AI and machine learning through three practices. We do training, strategy, and then the one we'll spend most of our time talking on today, which is model development and deployment.
And do you remember how you first got involved in the area of data management?
Yeah, I've been in tech for a couple of decades now as, sort of as engineer, startup founder, and an investor, both angel and venture capitalist. One way or another, I've been doing this for, I don't know, close to 30 years now. A couple of maybe career items of note that are relevant to what I do today. In the mid 1990s, I was a graduate student at Stanford, and I did my work in neural networks under Dr. Bernard Widrow. And at the time, I was a young graduate student. I thought, wow, this is great. Machines that think. I'm going to solve all these amazing problems. Of course, about 3 weeks into the coursework, I realized it was in the middle of the AI winter, and all the exciting things that I wanted to do weren't possible. So now, 24 years later, I finally get to apply my graduate degree and actually do real work with neural networks and machine learning. A couple other relevant career experiences. I ran the machine learning infrastructure at FINRA, which is the U.S. regulator for the NASDAQ stock market, and I was on the original deal team for the first investment by the U.S. intelligence community into Palantir. So one way or another, most of my career, I've been involved in data management in some form or another.
And so, for the benefit of software engineers and team leaders and heads of organization who are new to the concept of machine learning and artificial intelligence, can you give a bit of an overview as to what machine learning is, why it's relevant to them, and maybe give a bit of differentiation or clarification as to the differences between machine learning and artificial intelligence, at least as far as we'll use them within this conversation?
Yeah, great question. One of the challenges we run into is people use these terms so differently. You kind of have to check with your audience before you start having a conversation about them. So here's how we use these terms with our clients. AI for us just means intelligent software. So it's about as specific when as using the term the internet, right? And you can't start an internet project anymore, although I guess you could 20 years ago, but it just means thinking computers. And so I really think of AI as just a symbol that represents the era of the time that we're in. And it's a broad term for all kinds of technology. And sometimes that's really useful, right? If you're talking to a general audience, you want to be general about what you do. Machine learning is a more specific term and a more useful term, and it describes a different way of building software. We see people using the term machine learning when they mean something else. So I'm going to be very specific on my definition here by first explaining what machine learning isn't. So 99% of all software in the world is built by software engineers telling a computer explicitly what to do. And so software engineers are smart people, and they can read a spec or talk to a customer or look at a log file and generalize what needs to be done in instructions that tells a computer how to do something, right? And that's how most software is built. In machine learning is a different way of programming computers. Instead of having the software engineer explicitly tell a computer what to do, the engineer uses data to teach a model how to perform a specific task. So the engineering in machine learning involves picking the right model and organizing the data in such a way that you get a computer to do what it wants to do. For the purists out there, this is a technique called supervised learning that I'm describing, which is overwhelmingly the type of machine learning that's put into production today. and the most relevant one for probably most of your audience. So when people use the term machine learning, it has an implication of a different way of building technology that requires a different way of working, different skill sets, and a different infrastructure. As far as why is it relevant? I mean, most engineering projects don't require machine learning. Regular old software development is great for solving most problems. Developers are smart people, and if you have a relatively straightforward technical challenge that doesn't vary a lot, then writing a simple heuristic is great. You don't need machine learning to implement the rule. If X is greater than 10 and less than 20, do Y, right? You're better off just writing some straightforward heuristics that generalize the world and get the computer to do what you want to do. Machine learning is becoming more and more popular because the world's getting more complex. And as we get more and more data, as we more and more rely on computers for making decisions, and as we increasingly demand accuracy and precision from what our computers do, machine learning becomes a better technique for getting computers to do what you want to do. And so generally that's the difference between the two.
So at Prolego, your primary mission is focused on helping larger organizations get started with their first machine learning projects and help them establish the technical capacity to be able to build and maintain these projects in an ongoing basis. So can you describe how you identify potential clients and then execute on establishing a presence in the market that you're targeting?
So my business partner and I, Russ Rands, we started the company about 2 years ago, and we both recognized, or at least at the time, we had a hypothesis that large companies were going to need this technology. And in my case, it was a pretty specific recognition after my last startup. So the last startup I did before Prolego was a product company, and we were trying to do machine learning for content marketing. It was a terrible idea. I can say that because it was my idea. It didn't fit with the market needs. The data didn't match. In many reasons, it just wasn't a good space at the time for machine learning. But as a result of that experience, I would go in and talk to executives at big companies, and the long and short of the conversation was, Kevin, we like you. You're great, but your product is crap. But since you're in our office, can you tell me about this AI stuff? And what we both started to realize was that neither of us had seen such a demand, concern, enthusiasm about a technology shift since the internet in 1995, 96. And for those in your audience who were in their careers when that was happening, the internet was met with the same amount of confusion and enthusiasm as you have today. I mean, people would literally ask me, what is the internet and where is it? And we can't imagine the world without the internet today. But there was a time when big companies were trying to figure out, what do we do about this? Where does it live in the organization? Where does it go? How can we make money with it? What does it cost? And I began to see the same type of questions coming out of large non-tech companies. So for us, we spent the first 6 months out talking to the market and talking to executives about these type of problems. And what we started to realize was that the companies that were going to most need help from a company like ours were the large non-tech companies. So banks, insurance companies, industrials, manufacturing, automotive, the companies that don't have a strong existing technical infrastructure and resource. And so we began building relationships with all those executives, and by helping them figure out what this stuff is and what they can do with it. As far as like how do we establish a presence, I mean, the market is still pretty early, and there really are not a ton of companies like ours, at least that we have met. Most big companies are just now starting to bring their machine learning models online. 2017, the way I describe it, is the year of executives going to conferences. 2018 was the year of like actually putting some budget in place and building a team. And now in 2019, they're starting to ramp up and begin deploying models into production.
Yeah, and I recently went to the Strata conference last year, and I was struck by the fact that a lot of the presentations were focused on actual practical production uses for these different data oriented technologies, whereas in the preceding years, a lot of the conversation I had had was more in terms of let's just collect all of this data because eventually somebody will know what to do with it. And now it's much more focused on
Right.
we actually have a business case for collecting this data and performing these analyses on on it. And maybe we don't actually want all of that data that we've been collecting because of some of these new regulatory environments.
Yeah, boy, a lot I could say about that, including all of the money and time wasted, building the data, building this massive amount of data, and then discovering that a lot of it either you can't use or that it's not as valuable as you were hoping it to be. But yeah, that's actually, we see that a lot. But yeah, you're right. Now it's a lot more focused. Companies are getting a lot more specific in what they want to do.
And when you're speaking with your different clients and sales prospects, how much of your time and effort is spent on educating them about what machine learning and artificial intelligence are and the capabilities that they provide?
I would say every step of what we do is education. So it really is the foundation of our entire business. And I think that part of that might just be that this is how Russ and I work, and this is our personalities. But typically in a typical sales process, it'll start with either a conversation, or an executive will have read our book, and they're coming to us because they're trying to get started with this, or they're frustrated with the situation in their organization. 18 months ago, the questions were, hey, what is this AI stuff and what can I do with it? Now we're increasingly getting to the topics that you cover in your wonderful podcast here, which is, we're not getting what we were hoping to get out of our investment in this. We're not really deploying things into production. We've got a lot of infrastructure challenges. What can we do to overcome those? So the education part of it has shifted. It typically does still start with some sort of conversation. After that, we'll do a workshop or a webinar. Sometimes we'll come into a client site and just train them on the basics of some of the technology for a day. And after that, it's a strategy engagement typically, and then we go into the model development and deployment. But really, across the entire end to end, people are hiring us not to just execute on something for them, but to help them become a better organization and bring on the right people and the right process to do things themselves.
And when building a new machine learning project, particularly from scratch, where you don't have a lot of the necessary infrastructure in place ahead of time, what have you found to be the necessary set of technical skills and technical capacity and operating environment for being able to be successful in building and deploying these models?
So to get started, there are three specific skills that we suggest our clients begin ramping up in, and that's AI product management, which is just a product manager like you would think of in a normal context, except very specifically and focused on getting models built, identifying data, working through legal issues, kind of the wrangling of all the challenges you have to do something in a server side environment where you're building probabilistic models. So that's one skill. Those people don't exist. It usually involves taking some smart product managers in your organization, maybe with statistics or an engineering background, and teaching them on the job how to do it. And the second skill, the one that most people talk about, is the data science side of things, the machine learning engineer, the people that really build the models. Those are the folks that go out and gather the data, work with Jupyter notebooks, do the testing, the evaluation, put the models together, and try to hit some sort of benchmark. And the third skill, and the most misunderstood and the hardest to find, and the one you do such a great job of covering, is the data engineering. And that's the process of actually the person is going to take the models and put them into production, ensure they're reliable, they're doing what you want, and you have the infrastructure to be able to scale and iterate on them. So those are the three kind of skills we look for in the beginning. It's rare that a client has all three of those ready to go. They typically have pockets of these skills that are deployed across their organization. So we're usually involved in helping them figure out how they can either reorganize to bring a team together to execute on one of these projects, or bring in people to fill the gaps necessary for areas where they need help.
And as you were saying, it can be difficult to find a lot of these skill sets either internally or even as external candidates. So, wondering if you can talk a bit about your experiences of identifying people who don't necessarily come with the prepackaged set of skills, but have the necessary background or enthusiasm to be able to train them effectively and bring them up to speed in being able to help build and manage these projects.
Yeah, great question. I think one of the biggest mistakes we see is that an HR recruiter or a hiring manager wants to go and fill a data engineering position or a data science position. They go out and copy Google's job rec, right? And so what you end up doing is trying to compete with the same people that Google and Apple and Facebook are trying to compete for. It's really like all hiring. It's really just worth understanding what are the key skills you need and what kind of people can you attract and bring to your organization to be able to fill those. So there are a lot of people that want to get into this industry and a lot of people who are learning on their own. And if you package the opportunity the right way, you can attract those people. So my first piece of advice for anybody out there who's hiring is to sell the job. I'm shocked by how little effort most companies put into making, selling the opportunity to prospective candidates. I know there's legal and HR reasons for this, but if you're putting together a new team that you're going to try to use to transform your business, tell people that. I don't know if Tobias, if you saw any of the GE commercials when they were trying to rebrand themselves as a software company. There were TV commercials they ran. Did you ever happen to see any of
I did
those?
not know.
It was a campaign they ran last year sometime, and unfortunately, GE has run into so many. General Electric has run into so many other problems since then. But they really went out of a way to rebrand themselves as a software company by showing software engineers, chatting over a barbecue about how they're all the great engineering work they're doing at General Electric. And I mean, that's I'm not suggesting that anybody needs to do Super Bowl commercials, but when you're writing your job requirements, make it clear that your company's changing, that you're going to be different, and you're looking for talent to be able to do this type of work. So that's, I guess, my sort of general recommendation on this front. As far as the specific skill sets, on the machine learning side, again, one of the worst things you can do is copy Google's job recommendation. It really depends on what you're doing. If you're trying to advance the state of the art in a particular area that's critical, if it's computer vision or NLP, and you really need people that come from a research background, then you're going to have to get somebody with a PhD who's done primary research and built models. And there's a lot of people out there who have physics backgrounds and scientific and economic backgrounds that are really trying to get out of this. Maybe they don't like their academic advisor, or they decided academia is not for them, or they've heard data science is the way to go. So there's a lot of people looking for those opportunities. You want to find people who are good programmers and people who have some example of some history of shipping products. So an economist with a PhD with some Python skills, if the person can demonstrate that they're a good programmer and they know how to work in an operational environment, then that person is probably a good choice. On the data engineering side, as you all know, the challenge that you're dealing with is that you're competing with every organization that's trying to hire DevOps and infrastructure people. And as both of us know, there's a real shortage of that, and the prices for experienced people has really gone through the roof. So try to find people who have all the basic technical skills to be able to do this. They've got good server-side Python skills. They have basic DevOps skills, DevOps experience. They've worked with Jenkins, worked with Git. One of the ones we run into is make sure they can do SQL. When I started my career, everybody worked with databases and you learned how to program in SQL, but we're increasingly seeing more and more candidates who have worked with these object relational mappers, these ORMs inside frameworks like Django and Rails, and they don't really have the SQL coding experience. So those are really critical for you for attracting the right people.
Yeah, there's a great talk by Jez Humble talking about how to grow to your DevOps engineers internally rather than always trying to hire these incredibly experienced people from the outside, because as you said, you're competing against everybody for these people who are already at the top of their game when you have a huge amount of potential within your existing employees, and just giving them the opportunity and the training to get up to speed on these technologies and give them the space to learn and gain the experience necessary to help your organization be successful.
Exactly. Yeah, that's what we run into. But yeah, it seems like I guess there's an expectation that while this AI, this machine learning stuff is so hard, our people could never do it here. But if you look around the organization, you'll find people that are probably already self motivated. The person who's been programming in Python for 5 years who on their own is taking online courses and learning how data science works, learning how models work. I mean, these are the kind of people you really want to give an opportunity to.
And particularly, as you mentioned before, the majority of the actual work that's necessary for getting a machine learning project out the door isn't somebody who's doing groundbreaking research into new types of models or new neural network topologies, but somebody who's able to take TensorFlow or PyTorch or your machine learning framework of choice and put it to its best use of running it through model training and then ensuring that the model matches the expectations and then being able to deploy and monitor it in production.
Exactly. That's well said, Tobias. Yeah, most companies are not in a position where they're going to be pushing the state of the art. They need to leverage their data and their customer and their relationships and take what exists off the shelf and put it to work.
And so, with these different responsibilities in a data team where you have the data scientist and the data engineer, and in some cases, the machine learning engineer that sits somewhere in between those two, what are some of the potential challenges or tensions that arise in those team structures and some of the strategies that you've found to help ensure that the team reaches cohesion and is able to be successful in shipping the final product?
Yeah, this is the number one challenge that we see companies running into, and I could spend a lot of time talking about this. I spent a lot of time thinking about it and talking to clients about it. And the root of the problem is that data scientists and data engineers work differently, and they fundamentally think about the world differently. And what I mean by that is data scientists are in discovery mode. So even if they download an off the shelf algorithm, they're trying to use data to train that algorithm to do a specific task. And so it's very iterative, it's testing, it's exploring. It is really, Jupyter notebooks are called notebooks for a reason. It's like a scientist's notebook. And so 90% of what they do is getting thrown out, and maybe 95%. And it's just a small portion of that ends up getting deployed. So their entire way they work is designed for optimizing discovery process. And data engineers are doing operations. They're trying to ensure that things are reliable, do what they say, stable, testable, and can be iteratively improved. And these are completely different ways of viewing the world. And we run into a very common situation as we'll go into a client, and the machine learning team, the data scientists, have some brilliant people that have been working on a model for 3 or 4 months, and they've got their notebooks built, and they've got all their data in there, and they've got all this code running, and then and it becomes time to deploy the thing, and management hasn't thought about this in advance, so they sit down with the developers, and say, hey, here's our notebooks, can you guys deploy this? And the programmers freak out, right? Because they look at this code and think, oh my God, I don't understand what this stuff is. They're not maintaining state between these styles. What is this notebooks? And that was my reaction the first time that I saw this. So as far as what can you do about it, I think first of all, just recognizing that people are coming at this from two different perspectives. They're not easily going to work together. And the process of taking notebooks and putting them into production is a complicated one. So as far as I can probably get into the actual development process a little bit later, because there's more I can talk about that. But as far as improving communication between the two, the more you can get your data scientists becoming better programmers, the more they can abstract things in their notebooks into classes and methods, the more they can organize their notebooks into a serial workflow that an engineer could easily translate into a production application, into a data pipeline, the better that communication is going to be. And by the same token, the more your data engineers know about data scientists, if they've taken a basic data science course, if they know what Pandas is, NumPy, the basic data science stack, they're going to be able to understand what the data scientist is doing a lot better and be able to put things into production.
Yeah, there's a great interview that I did earlier as well with Matthew Seal from Netflix about their experience of trying to build a unifying environment for using notebooks as the common method of communication between the different roles in the team as well. So I'll put a link to that in the show notes. And on the point of trying to build empathy between the data scientists and the data engineers and trying to bridge the sort of inherent conflict between their roles, there's another interview I did about that as well. And I did a presentation at DevOps Days Boston on the concept of DevOps for data engineers, which I'll add a link to the show notes as well for anybody who wants to dig a bit deeper into some of those various topics.
Yeah, your interview with Matthew Seal was excellent from Netflix. The way he talked about how they're doing it really covered a lot of the major challenges we see with companies that want to put notebooks into production. And I listened to it at least twice and was taking notes and sort of very carefully tried to parse his words. But I would encourage caution to any companies out there that want to start by putting notebooks into production without really thinking about the infrastructure implications of what they're doing. For most of our clients, unless you're doing something that's relatively straightforward, notebooks into production is probably not where you want to start because you don't have Netflix's existing infrastructure that's able to handle this type of unstructured environment and code where you can't maintain a state. Just out of curiosity, have you seen any of Joel Gruss's work? He has a great presentation where that's called, and then we can put this in the show notes as well. But I don't like notebooks, and he gave this presentation at the Jupyter conference. It was all of it, basically bashing notebooks for 45 minutes.
Yeah, that was. I saw the slide deck. I didn't see the presentation yet, but it's something on the order of 130 slides that he zips through to cover all of the different shortfalls with notebooks as a development environment and some of the ways to work around it and improve the overall workflow. So I'll definitely add a link to that. And he also wrote a good book about data science from scratch for anybody who wants to get a better understanding of some of the fundamental principles and algorithms behind what powers a lot of the current set of data science tools.
Yeah, he's got some great resources, and the first time I saw his notebook, it was crazy. It was like 150 slides, and there's animation in there. So I don't know if you've ever heard him speak, but he's also a comedian, so he's fairly entertaining. So I think a lot of his advice was designed to be entertaining more than educational. And I have to say I do like notebooks. I think they have a great use. We use them all the time, But I think he does bring up a couple of good points of the challenges of maintaining state and structure and why it's difficult for some engineers to be able to use them.
And so, moving into the actual project phase, can you give a brief discussion of the steps involved in developing a first machine learning model and putting it into production, including some breakdown of where a lot of the time was spent at the various stages?
Yeah, I can actually walk through a really specific project we did last year because we went to some ends to try to document the time we spent in different phases, and it was the first one for a company, so it's probably a good use case. So in this instance, it was a large Fortune 500 company that had done very little machine learning. They had a new data science team, and they had spent some time doing a lot of data gathering and data cleanup, but they really weren't sure what models they want to put into production. They had a bunch of ideas. And so we started working with them and helped them think about a couple of different initial models they could put into production. The one that they decided on was to predict how long a particular internal business process would take. Usually we find that, when you ask management, what do you want us to work on first? They come up with we'd like you to build an AI system that can, automate what these 5,000 people are doing. They aim for the stars, not realizing that they're asking for something that's going to take 10 years. And so part of our work is being able to educate them on making the choice of the right problem to solve. So one of the most frequent ones we suggest is actually predicting how long a business process will take. And the reason it's a good first choice is because technically it tends to be fairly straightforward. You tend to have plenty of training data. It's easily interpretable. You don't have to get into a debate about how long something is. Time is time, and it's usually in your database, and it's a number of days. And usually you can rely on off-the-shelf models from scikit-learn or one of these stacks to be able to do the predictions. The benefit of doing something like this is a project like this is that you can almost immediately apply it into your operations because if you can predict how long a business process is going to take at the outset, then management or operations can intervene and try to improve things. And you get an opportunity to begin building out all of the infrastructure and process and team development you need to get your first models up and running. So our number one piece of advice when companies work on their first model is to get it up and running as fast as they can. And that's because often the biggest risks in these kind of projects are that nobody's going to use it or it doesn't really provide the business value you need. So in this particular instance, we got the first release up in 65 days. And this is a company that they just had some data. They had very little infrastructure. And then after the first release was done, we worked through 2-week release cycles over 5 releases that resulted in a 47% improvement in how the model works. And so I like to use this in examples when we're doing planning other projects because it's an example of how a big company can get things up and running without spending months and months and months training models or wrangling data or all of these things that you don't often need to do when you're trying to get off the ground for the first time. The biggest value in the entire process was actually putting a first thing into production. And that allowed the team to begin doing everything you need to do to machine learning. Help people understand what a probabilistic model is, help them build their first data pipelines, help them build their first set of metrics, help them realize the need for data engineering and the shortcomings in the team that they had, and then the tools for putting models into production. So that was one example.
And once the model is in production, I know that there are various metrics that are useful to track to ensure that you don't have issues with model drift and ensure that you have the standard set of operational metrics of system performance and memory and CPU usage, and particularly in the case of machine learning or deep learning networks, any GPU usage. So what have you found to be the most useful metrics to track and the most useful ways to track and analyze those metrics to make sure that the model is running effectively and signal when you need to potentially retrain the model to redeploy it?
Yeah, we usually find that most of our clients are pretty good at tracking the infrastructure level metrics. Knowing when they need to go up to a bigger GPU if they're doing deep learning or they're running out of memory. Like that stuff they usually have a pretty good handle on that. What we find is that people don't necessarily, or not at least initially, not really ready to think about what probabilistic models do and what they need them to do. And so we start out by kind of walking through the example of, okay, what is your model going to do? And they pull in data and they make probabilistic predictions. And the challenge with this type of infrastructure is that it's not always obvious if there is a problem. So if your business is running a recommendation engine and it's making lousy recommendations, customers don't call you up. No one's ever called up Amazon and said, hey, you didn't recommend great products to me, right? They just don't buy. So you have to be able to have some infrastructure in place that tries to alert you to your biggest problems. And usually those are, is the data there? Or, are you getting all the data you need? Or is it just suddenly just all is a pile of nulls in the database? Is it in the right format? Is it in the acceptable bounds that the models expect? Usually we find situations where clients are subscribing to some third-party API. Well, that company can release or change its API anytime. And if your models rely on that, you need some sort of validation check that ensures that it's within the bounds that the model expects. And usually you can get away with really simple stuff. So just run a standard deviation or variance and a mean on a certain set of the input data, and have some alert that goes off if it gets outside of those. That'll take care of 99% of your problems. And then on the other side of the model, on the output, making sure that your model's within some acceptable bounds. Are you getting, if you expect 5 recommendations, are you getting 5 recommendations? And finally, the one that is the one that I see missed the most time is actually ask if anybody's using it. Like, are people using your model? Are customers, of course, if you have a recommendation engines, are you improving your recommendation? But if you have a model that's producing something for an analyst or a sales team, go ask them, are they using it? How do, if so, how? I can't tell you the number of times I've seen, companies put together a lead scoring or some other tool for their sales team, and you sit down with the sales team and say, hey, how's your lead scoring work? And they say, well, we don't use that, we still just call everybody, right? Well, it doesn't matter how good your model is if nobody's using it. But then beyond that, some of the metrics you measure, infrastructure, memory usage, CPU, GPU, we usually find that companies have a pretty good handle on those things.
And as far as the actual deployable artifact, when you are releasing to production, what are some of the common ways that is built and managed, and the format that it actually takes for anybody who hasn't encountered that before?
Yeah, I think I think people are surprised the first time they see an actual model because there's all this mystery around it. But usually in the model itself is just a file which gets loaded into an algorithm. The algorithm is typically a Python library or some sort of module that you build yourself that maybe wraps around it, or if you have your own custom code. So the model itself is fairly straightforward to deploy, and sometimes it's just running on some API that is set up to receive a JSON call. The complexity is everything around it. And so it's the process of ingesting data, of validating, of transforming it, of training the model, and then deploying itself. And that's really where the challenge comes in, and building that pipeline and that infrastructure. It's just a set of connected Python codes that run in a data pipeline, but that ends up being the harder part of deploying. We see there's basically three ways you can do this, and two of them I don't usually recommend. If you think about what you're doing in machine learning, you have a data scientist that's working in a notebook and they create a model, and then they store the model as a file somewhere, and then at some point you got to deploy that. Well, the three approaches to doing it that I've seen are they deploy notebooks, and your interview with Matthew Seal really covers an excellent infrastructure for doing this, and when you want to apply that kind of to be able to deploy notebooks. But I think there's a lot of deploying notebooks can work well if you're doing some analytics, if you're maybe producing a CSV file that your marketing team is going to run and use it for a campaign. But if you're actually talking about machine learning models, there's just a lot of risk into doing that, especially because it's very, very easy for a new team to get sloppy in how it deploys notebooks. If you want to try to take your entire ingest, transformation, validation, prediction steps and lay that up in a series of Jupyter code, it's very difficult to do unit testing, and it's very difficult to deploy, debug, and improve. So what we recommend for people is to use the notebook as the handoff between data science and data engineering. So you work on 2-week release cycles, have your data engineers that are staggered 2 weeks after data scientists, and use the notebooks as the interface between the two. And if you do that, the data scientists and data engineers will naturally get to understand what each other's goals are, and they'll get good at doing a deployment process. Yeah, admittedly, it's not ideal because you do have some duplicated work. You have code that's done in a notebook that has to be rewritten into a Python application, but it's the most reliable way we've seen for a team to get started with their initial deployment of machine learning models.
And then, as far as the basic technology stack that's necessary for building out this pipeline and putting those first machine learning models into production, I'm curious how the build versus buy debate breaks down, particularly given the amount of open source that's available, but also with your particular client set being larger organizations. Just what that discussion looks like for you, and then the types of products that you typically recommend to your clients.
So as far as build versus buy, I approach this like I do with any, at the first pass, I approach it like I do with any software buy versus build decision. And that is, generally speaking, you want to buy things that are non-competitive, and you want to build the things that are strategic and you need a leg up. So for example, you wouldn't go out and build a customer relationships management platform, right? Because there's a bazillion of them, and you can just go sign up for Salesforce. You're going to be competitive based on how good your sales team is, not how good the tool is. So as an example of, you would never want to build something like that. And as AI starts to evolve, there are going to be some fundamental building blocks that you can just buy from a third party. At some point, there's going to be a good level 0 NLP help desk solution that you're not going to want to build yourself, because you're going to be able to buy one off the shelf from Amazon or some other vendor. But if you have something which is competitive, if your recommendation engine is very specific to your products, and it's something that's going to drive revenue and it's going to drive your sales team, then you probably want to build that in-house and you want to own it, because Amazon's off-the-shelf recommendation engine probably isn't going to do what you need it to do because your business is different. So that's the first consideration. The other consideration is data. And so when I ask, when companies talk to me about hiring a vendor, turning their data over to a vendor or a startup to do something for them, I talk them through the issue of what happens, the loss of control over their data. And it's despite whatever contractual structure and constraints you put into place, you can tell a company, hey, you're not allowed to train competitors' models on our data, and our data has to be isolated and only make predictions on our tool. But the reality is, the way engineers and the way data scientists work is extremely hard for that to happen in practice, because just the fact that just by the nature of their work, these engineers are trying to make their models better and better and better, and they're using client data to do that. So one way or another, you have to be extremely careful about your data not being abstracted into the product in such a way that's going to benefit your competitors, because that is your most valuable asset. So those are usually the two questions I ask people. Now, there's some times when you could care less about the data. And my favorite example of this is Expensify. So I don't know if you use Expensify, but it's a venture-backed startup that manages corporate expenses, and they use some NLP and some computer vision in there to make it a lot easier. It's a fantastic product. We use it, but there's not too many companies that are concerned about maintaining control of their employees' restaurant receipts. Right? If Expensify can use all that data and make a better product, hallelujah. You don't care if your competitors know where you ate last night. So it really depends on those two questions. How competitive is it, and how important is proprietary ownership of your data? As far as products that we recommend, I think that the kind of stuff we recommend is really the stack that most of your audience is familiar with, and what I hear you discussed on most of your other podcasts. So obviously, if you're doing anything into any kind of deep learning, NVIDIA is the only game in town. So it's NVIDIA GPUs. I don't think I've seen an instance where anybody's using anything else. I know there's Intel and Google are coming out with competitors, but for the most part, they're just the tools that NVIDIA has are better. We recommend the Python stack that pretty much everybody else works with: Jupyter Notebooks, NumPy, Pandas, Scikit-learn, PyTorch. If you're going to be building in-house, use all those open source tools. As far as model deployment goes, increasingly we see Airflow becoming the tool of choice. And if anybody wants to learn more about Airflow, I would highly suggest they listen to episode 43 of your podcast. Your interview with James Meikle on a new Airflow installation was excellent, and really covers a lot of the key issues that we run into in using Airflow. So those are the main tools. And after that, it's the typical DevOps stack: Git, Jenkins. And then when it comes down to monitoring, is either the tools on Amazon, or most companies have their existing production operations team that can monitor models for them.
And in terms of deploying the models and managing them, what are some of the major risks that you would call out for anybody who is first exploring this space and wants to have a successful launch of their first product?
So I think that our number one recommendation for avoiding product failure is get your model in production as fast as you can. So the biggest risks we see are people waiting too long. If your team is still gathering data and training the model, months after starting, it's really worthwhile stopping everybody and trying to make sure that you're on the same page and you're aligned with business goals. Most of the problems can be dealt with. You're only gonna know when you deploy a model. So it's much better to deploy something today, even if you have it in a non-production format, that gets you 90% accuracy, rather than trying to spend 9 months getting 97% accuracy, because you're not really going to encounter the challenges until you go live. And I think once you go live, the first question I would ask is just kind of taking a step back and looking at your operations and what are you trying to accomplish, and where's the biggest risk? If you're deploying a recommendation engine, then your biggest risk is that you make a wrong recommendation. That's not catastrophic, right? I mean, it's not like, nobody's going to call and scream and yell because they got the wrong recommendation. They're just not going to, they're not going to buy. So it's a type of model that you can put into production quickly without a huge amount of production risk. If you're going to be launching rockets into space, or you have a battlefield technology that's got to intercept missiles, obviously you're dealing with an entire different level of testing and validation that has to be present at that point. But we find, for the most part, in terms of like testing models and good validation sets and making sure there's no bias, most of the data scientists are really good. If you follow the basic advice in terms of setting up a correct test set, setting up a correct validation set, testing for overfitting. If you do the basics, you can hit 90% of the problems. Where we see, where we run into challenges is when, teams are just, it's their first time and they're not really focused on putting together a good test set, and they introduce a model into production that's overfit. It just doesn't generalize well when they go into production, but we don't really run into that often.
And for any software engineers or team leaders who want to break into machine learning as a career path, what are some of the data engineering and statistical skills that you would suggest they learn, and any advice that you have in terms of positioning themselves for the right opportunity, and maybe any useful references that you might suggest?
It's a great question. In fact, I think if any software engineer, any server-side software engineer, is feels like they're in a kind of a career rut, I would really highly encourage them to take a look at machine learning. And so, and by that I mean go online and take a couple basic data science courses. You don't need to become an expert in being a data scientist, and you have to know how to use notebooks, how to use NumPy, how to use Pandas, how to build a model. Once you understand what overfitting is, what training data is, what epochs are, just understanding the basics is going to really help your career. If you want to do more, I would highly recommend Jeremy Howard's Fast AI course. It's the best out there, and his explanations. And if you can get through his course, it really will demonstrate your understanding of the fundamental building blocks of this technology. Beyond that, get good at your basic Python application development and DevOps stack. So the standard type of tools that you would work with in any large data infrastructure environment: AWS, Git, Jenkins. Building good Python code, learning how to build good test code, unit tests and integration tests. All those basic software skills are good. And then finally, if you can start playing around with Airflow, maybe find a notebook or a basic model you build in the data science course and turn it into an Airflow pipeline. That's something that not a lot of people are doing. But I guess more than anything, I would just go out and look for these opportunities. I mean, if you have, go to your manager and repeat this one very simple sentence: I want to help data scientists put models into production. Because not many people are explicitly saying that they want to do that. Everybody wants to become a data scientist. Nobody that's in machine learning wants to do all the plumbing. And if you actually can position yourself as somebody who's excited about that, is taking the opportunity to learn this valuable and hard skill, it's really going to position you for some great opportunities.
And are there any other aspects of bringing machine learning into production, or the data engineer and data science career track, or anything along the lines of what you're doing at Prolego that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I would guess maybe the only other advice I would get is if you've spent a lot of your career, the past 10 years working with Django or Rails or one of these frameworks, take the time to bone up on your SQL skills. There's just so many instances where good SQL skills come into play when you're trying to pull data in, when you're building models, or when you're actually trying to put something into production. I'm surprised at how many junior to mid-level developers just have not had the opportunity to spend a lot of time doing SQL. So it's not everything is going to be an active record in Rails, and if you can get some good SQL skills, that'll really benefit you.
All right. Well, thank you for all that information. And for anybody who wants to get in touch with you, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think it's the one we discussed previously. It's getting Jupyter notebooks into production. And so it's basically taking a notebook, something that a data scientist creates, and deploying it. There's really only three ways you can do it. One is that you don't use notebooks at all. You take the Joel Gress approach. The second is you try to put notebooks into production, and then you're going to be dealing with putting together some more complicated infrastructure to manage that. And the third one is where you have some sort of handoff between the machine learning engineers and the data scientists and the data engineers. So I think that's the biggest challenge we see. And I think if anybody's looking for a good startup idea, that's one of the more interesting problems I think our industry needs.
Well, thank you very much for all of your insight into the current state of the machine learning industry and the advice that you're providing. I'm sure that a number of listeners will find great value in that and possibly encourage a few people to change their career track. So thank you for that, and I hope you enjoy the rest of your day.
Thanks a lot, Tobias. Appreciate it.